Hi, I'm Kim Williams from Kansas State University. This eGrow presentation introduces the idea of the nutrient management triangle, which provides a framework for thinking about the interrelationships between the practices of irrigation, fertilization, and root substrates during greenhouse production. Most growers know, as a matter of intuition and experience, that their irrigation practices, fertilization program, and substrate characteristics are all interrelated, and successful nutrient management requires an understanding of these interrelationships. These three aspects of nutrient management form the nutrient management triangle. The nutrient management requirements of a particular crop can be visualized in the center of the triangle. If there's a change made to a component on one side of the triangle, a change in a component on another side is usually necessary to preserve the growth, health, and appearance of the crop. The purpose of this eGrow topic is to consider how to apply this conceptual framework to system-level decisions about substrate selection, irrigating, and fertilizing. While the framework tends to focus on the physical and chemical dimensions of nutrient management, biological properties are also a key aspect of plant nutrition as well. All interact with each other and play into the discussion. Let's begin by thinking about the obvious relationship between a substrate's physical properties and irrigation frequency. Tighter mixes, or those that hold more water, typically require less frequent irrigation because the substrate does not dry down as quickly. A specific connection between a dribble tube irrigation system and the substrate's physical properties is the percolation rate of the mix. Substrates with high pore space volume may allow water from a drip tube to percolate through it too quickly so that the entire substrate volume is never thoroughly wetted, sometimes over the course of the entire production cycle. In this case, a very porous substrate is just simply not compatible. It's not a compatible choice for use with a dribble tube irrigation system. Similarly, sub-irrigation systems require a tight enough mix to result in fertilizer uptake through holes in the bottom of the pot and movement throughout the root zone via capillaries or small pores in the mix. This mechanism of water and fertilizer distribution via capillary action only functions if substrate pores are small enough. Incorporating a small percentage of substrate components like pasteurized soil or small particle sizes of calcined clays will increase water retention of the substrate and decrease irrigation frequency. While it makes these hanging baskets in the photo heavier, one advantage is less frequent need for irrigation in the market channel, and that's a key reason why the grower does it. If we consider a key relationship between irrigation and fertilization, we should be aware of the volume of solution that's leached. As the amount of leaching is reduced, the rate of fertilizer concentration applied should also be decreased. No leaching occurs via closed sub-irrigation systems, and this contributes to the need to use a lower fertilizer concentration. But with an open overhead irrigation system, like hand watering or spray stakes, on the other hand, the volume of irrigation solutions that's leached from the containers should be managed by growers. The greater the percentage of applied solution that is leached, the higher the fertilizer concentration that's needed to build adequate levels of nutrition in the substrate. So, this is an important relationship between irrigation and fertilization. Large leachate volumes require higher fertilizer application rates than small leachate volumes. The best leaching fraction for a given crop is dependent upon the crop's sensitivity to salts, substrate porosity, irrigation water quality, and the volume of water required to wet the root zone, among other factors. Clear irrigations can be used to leach nutrients from the pot, especially with applications of large volumes of water. Clear irrigations can be alternated with higher rate fertilizer applications or used as a means to reduce salt buildup in the substrate via leaching. So, the interrelationships between substrate and irrigation system require that we match these two aspects of nutrient management. Drip and sub-irrigation only work if a substrate's percolation rate and water uptake via capillarity are compatible with the function of the irrigation system, and the rate of fertilizer that's chosen is in part associated with the type of irrigation system and the amount of leachate that occurs while using it. As we turn our attention to the relationship between the substrate and the fertilization program, we can extrapolate the frequency of irrigation idea a bit further. Because soluble fertilizers are applied during irrigation events, our ability to get fertilizer to the crop is usually inherently tied to the crop's need to be irrigated. Frequency of irrigation also then dramatically influences the rate of fertilizer that will need to be used. Consider then how we might apply the concept of the nutrient management triangle to this simple idea. We can alter the substrate's water holding capacity by increasing or decreasing the percentage of material like perlite based on season of the year. For example, a crop's needs may dictate that we use a more porous substrate in the winter to contribute to faster dry down when temperature is cool and light levels are low. While plant growth is slower this time of year, we still need to get fertilizer to the crop, and this can be accomplished with a looser mix that has had porosity increased simply by upping the percentage of perlite. In the spring and summer, a tighter mix may make more sense because the higher temperatures and light intensity drive more rapid plant growth as well as substrate dry down. A grower is irrigating so frequently and thus delivering nutrients to the crop so frequently that a decrease in the percentage of perlite can tighten up the mix to help reduce the need for such frequent irrigation and thus fertilization. Another aspect of the substrate fertilization relationship that we must not forget is that pre-plant substrate amendments like dolomitic lime, gypsum, and micronutrient mixes provide nutrients, and therefore they're an important part of the overall crop fertilization program. A less important connection between the substrate and fertilization is that substrate chemical properties, that is, a substrate's cation exchange capacity, which influences nutrient retention in the pot. This relationship is not as critical in our soil as substrate production systems, during which we can easily provide nutrients via soluble feed. But the point is that we can select substrate components that will help keep nutrients in the pot and abate excessive leaching of them. The relationships of the nutrient management triangle suggest a flexible substrate recipe. Use of a substrate that can be slightly modified based on different crops' requirements, seasons of the year, and frequency of watering. In combination with consistent and repeatable substrate handling and irrigation practices, the grower can optimize nutrient management for any given crop. Test your understanding of the nutrient management triangle by considering the impact of the plastic tray under each pot shown in this photo. What effect does the tray have on frequency of irrigation and fertilizer rate? Well, because the tray turns the irrigation system into a quasi-sub-irrigation system, both management factors of irrigation frequency and fertilizer rate will decrease with the use of the trays. How would you reason through the effect on substrate selection for use with this type of production system? To close, I'll add two more quick thoughts. First, note the production environment, that is, temperature, light, humidity, and even carbon dioxide levels also interact with nutrient management. I was referring to such relationships when discussing how the substrate water holding capacity might be altered based on season of the year. And finally, note that all aspects of nutrient testing, from routine pH and EC analysis to plant tissue analysis and visual symptomology, all contribute information that allows growers to adjust their nutrient management program. These topics are covered in other eGrow modules. Thanks to the Fred C. Glockner Foundation for supporting eGrow University.